Merci. Bonjour tout le monde. Afternoon all. It's good to attend an NHQ meeting again after an absence of some 8 years, during which there have been also demands on my time. The topic on which I'd like to speak is an extensive one, and my discussion will be no more than an overview. I hope that in another form I will be able to give a more complete account. The late 18th century and the first half of the 19th century saw the emergence of the Australian continent from a partly defined landmass to a recognizable entity. The charting of its coastlines, mainly by Dutch, English, and French navigators, gave it its shape and resulted in the publication of the first complete map of the Australian continent, which you are now seeing on the screen. I'll come back to that. The observations and explorations of its solid ground by scientists and naturalists who accompanied the early expeditions of discovery provided illustrations of its physical features and descriptions of its rock formations and revealed the presence of a unique flora and fauna. The French expeditioners also gave some 650 names to Australian localities, some 300 odd of which are still used today. Over an almost 50-year period, extending from 1792 to 1840, French expeditions of discovery played a significant part in this portrayal of the southern continent. Before the 1970s, Australia had already been visited by French navigators. Louis Alénor de Saint-Laurent had claimed sovereignty over the west coast of Australia for France, a claim which was never followed up. On se demande en Australie ici. Je ne sais pas. Marion de Fresnay visited Tasmania in 1772, and of course the ill-fated Pérouse spent 6 weeks in Botany Bay in 1788. Some 5 years later, in 1791, the expedition commanded by Bruny de Castor was dispatched to the Antipodes and the Pacific with instructions to search for the missing La Pérouse, but also to charge parts of the yet unknown coast of Australia and to study its natural history. That is the map in existence when the de Castor expedition arrived. The expedition would not discover the fate of La Pérouse, but succeeded in mapping parts of the Australian coast, particularly that of the southwestern part of the continent and of Tasmania, for which the hydrographer for Baudin, missed out half the name, deserves most of the credit. This was a time of intense interest and engagement in science in Europe. The vast accumulation of new knowledge and fresh concepts made it desirable to appoint specialists in the newly recognized disciplines of science and voyages of discovery. The authorities in France responded to this need by appointing the well-qualified Jean Blavier as the expedition's mineralogist. His withdrawal from the voyage at Cape Town was an unfortunate loss. The surgeon naturalist Claude Riche, who had a basic knowledge of geology and field experience in Languedoc, I should move on, took over this responsibility. Unfortunately, his journals and his collections were confiscated at Batavia and never recovered. However, his commander, Don de Castro, copied parts of Rich's observations into his own journal. So we know that Rich, when he set foot on the shore of Australia and found outcrops of granites on the shoreline, followed inland by a flat, extensive terrain without any mountains in sight, and having before that been informed that granites always form the core of mountain ranges. Well, imagine his astonishment when he found himself faced with a quite different situation. And future naturalists would also have their acquired knowledge of geology challenged by observations in Australia. My voice is going. It was Don de Castro himself who commented on the geological formations overlying the ancient rocks over vast stretches of the continent's southern coasts, when he observed every bit of the coast that was sighted to the east and west presented the same appearance, that of a steep calcareous rock of equal height in its whole expanse, the layers of which were completely horizontal, as well as the plateau on the summit. On the southern coast of on the southeastern coast of Tasmania, the expedition's botanist Jacques-Julien Houtou de la Patière discovered a coal seam interbedded with sandstone. And being aware that sandstone and coal was often found in association, he predicted that more coal would be found underground. He was correct in this prediction, as many years later a more substantial coal measure sequences were discovered in this area. Some 10 years later, in 1801, the expedition led by Nicolas Baudin reached Australia. It may be counted as the most successful in terms of the contribution it made to the charting of its coastline, the range of its scientific discovery, and the size and variety of its natural history collections. The expedition's 2 ships carried a large contingent of scientists, in fact some 24 who were classed as scientific personnel. They included gardeners who, in those days, of course, had a considerable knowledge of botany. And they also included 2 mineralogists. During their lengthy stay in Australian waters and their charting of its southern coast, they could confirm, or they could finally lay to rest, the long-standing speculation that Australia consisted of 2 parts separated by a north-south strait. As I showed before, the first complete map of Australia resulted from this expedition, which shows the continent as one. Oh, yeah. The 2 mineralogists, Louis de Puch and Charles de Beau, no portrait, unfortunately, were respectively graduates of the École des Mines and the École Polytechnique. De Puch was in fact born only a few kilometers away from here. He was the senior mineralogist. He became ill during a stopover at Timor, and François Pérouse, who was appointed as the expedition's zoologist, took a much greater interest in the geology and made some significant contributions. De Puch had studied under Dumont and applied the latter's 4-fold classification of rock formations to Australian sequences of rocks. Like Lariche before him, he accepted that granites belonged to the first formed or primitive rocks and formed the cores of mountains. His observation of pebbles of granites carried by rivers from higher ground in the Blue Mountains, shown in the map here, if you can find it, west of the Sydney Basin. It proved to him the truth of this idea. The sighting of a chain of mountains from out at the sea, and from some information gained from other colonists, convinced the French that the Blue Mountains was not just a single isolated mountain range, but was part of a much larger range. And in so saying, they predicted the first existence, they predicted as the first the existence of the Great Dividing Range in eastern Australia. The examination of the terrain some distance inland from Sydney and his knowledge of that coal seams are cropped out to the north and south led Bailly to conclude that coal formation was continuous between widely separated outcrops, and in making this assumption foreshadowed the existence of the Sydney Basin. Of particular interest to readers of the expedition's finding was the discovery of living mollusks known to be extinct in Europe. Both Pérouse and Bailly made such finds which prompted the German naturalist Leopold von Buch to question the view advocated by Werner that sediment had been deposited uniformly in a universal ocean, and led von Buch to suggest the possibility that local sedimentation may have produced unique deposits in Australia. The deaths on the return voyage of both Baudin and Depuch, and the loss of the latter's journal has denied us a detailed account of his geological assessment of the continent. Bailly's catalogue of his rock and mineral collections has survived, but his contributions seem to have been largely ignored. Von Buch was the last to see this collection in Paris, I think at the École des Mines, and it has not since been seen. The scientific personnel on the first two French expeditions had been civilians. And with the expedition of Louis de Freycinet in 1817-18, there was a major change. Louis de Freycinet had been a lieutenant on the Baudin expedition and was the witness of some considerable discord between the commander, the scientists, the officers, with regard to the time spent by the naturalists, the scientists, on shore. Baudin was, of course, limited in allowing them to go on shore because he had other considerations to take into account, like winds, weather, and so on. Scientists wanted to go on shore. They were enthusiastic. It was an unexplored land. They wanted to see it all. So there was considerable discontent. And Freycinet wanted to avoid that on his ships. So he used his two naval surgeons as naturalists as well. These were Jean-René Constant Croix and Joseph Paul Gaimard. While these medical doctors had a broad knowledge of the natural sciences, they lacked a deeper understanding of respective scientific disciplines. Nevertheless, they made important observations and collected specimens during their brief stays ashore. Their contribution to Australia's natural history is rarely acknowledged and deserves greater recognition. Croix and Gaimard were now able to cross the Blue Mountains, which a route had recently been discovered there, and they could confirm the Depuch's prediction that granite did indeed underlie the sedimentary sequences in the Blue Mountains. The next two French expeditions commanded by Louis Isidore, I better move on. Louis Isidore and Louis Isidore Duperrey and Hyacinthe de Bougainville, respectively. Bougainville was, of course, the son of the more famous navigator of earlier days. And Duperrey's surgeon was René Lesaux. And I don't think I said that the policy adopted by Freycinet to appoint only naval surgeons was followed by all future expeditions. So it was René Lesaux, the surgeon, who made by now the obligatory crossing of the Blue Mountains. And I think he was the first to describe the sequence of the rocks encountered on the way across the mountains. And on the other side, he examined the recently discovered limestone, which was so important for the building industry in Sydney, and which had been lacking for years and years. It took some 10, 20, almost 30 years to find limestone. Move on. Bougainville is probably best remembered in Australia for having commissioned the memorial to La Pérouse in what is now the suburb of La Pérouse, the Sydney suburb of La Pérouse. Now we come to the voyage of the second of the voyages of Dumont d'Urville. He had been a lieutenant on the voyage of Duperrey. And this, his second voyage, took him across from Western Australia around the southern coast of Australia to Hobart. And he was accompanied again by the surgeons Croix et Gaimard, who made a second trip after having been there already with Fresnay. During the stopover at King George Sound in Western Australia, the two surgeons were eager to verify reported findings of fossilized corals on a hill more than 100 meters above sea level. This was first. These were first found by the expedition led by George Vancouver in 1791. They found instead stony branches of tubular objects, which they correctly interpreted as twigs and roots that had decayed. Croix also recorded basalt on the coast of Victoria and was delighted to find living specimens of the mollusk Trigonia east of the New South Wales coast, which he only knew as fossils from the Paris region. Then in 1939, Dumont d'Urville made his third voyage to Australia, another voyage around the world. And as part of this, he made the perilous voyage from, does that show up? From southern Tasmania across to Antarctica, which led to the expedition's greatest achievement, the finding of land in the South Polar region and the fixing of the position of the South Magnetic Pole. On this occasion, the two naval surgeons were Jacques Ombrun and Élie Jean-François Le Guyot. Again, no portraits available. Ombrun took a great interest in natural history, particularly geology and mineralogy, and had made some astute geological observations, particularly on the formation of volcanic islands. He found some time to explore the regions around Hobart and to collect some specimens of rocks and fossils. However, he was mainly occupied in caring for the many ill members of the crew in a makeshift hospital in Hobart and was not able to make the voyage to Antarctica, leaving the duties of naturalist to his colleague Le Guyot. Sailing in waters often surrounded by floating islands of ice taller than the tops of their ship's masts, they spotted dark patches in the distance, which were soon identified as ice-free land. Boats were launched on each ship and had to cover a distance of some 6 miles at sea to make the first landing on firm soil in Antarctica. It became known as, or was named Rocher du Bargamont. The crew set out to collect geological specimens using pickaxes and hammers and try to break off specimens of the hard rock without any success. Fortunately, they discovered small pieces of the same rock lying about in quantity enough to make one officer say there was enough to supply specimens to all the museums in France. Not many of these specimens seem to have been returned to France, unfortunately. But I'll show them in a moment. First, Dumont d'Urville recognized these specimens as nice. An officer on the ship, Dumont d'Urville recognized them as granite. An officer on the ship recognized them as nice. And with the benefit of today's analysis, they're now described as paranise and amphibolite. These two specimens are from the collection of the Muséum National d'Histoire Naturelle, which I have seen. Unfortunately, the collection of Dumont d'Urville is pretty completely preserved there in the museum. Unfortunately, I've seen very little of the specimens from the Fresnay expedition, which were also deposited there. But I don't know whether only very few came in after the ship's shipwreck on Falkland Islands. Now, the French visitors raised the French flag on land, which no human had either seen or set foot on before us. Later, the commander announced that to the assembled officers and crew on his ship that this land would henceforth be known as Terre Adélie, the name of his wife, who has 3 times consented to a long and painful separation to allow me to accomplish the faraway projects of exploration. In the introduction to his voyage, Dumont d'Urville acknowledges the difficulty faced by naturalists in exploring the lands they visited, given their often limited time spent ashore, and he recognizes that this particularly applied to geological investigations. In some rather astute comments, showing a surprising understanding of geology, he stated that the geological observation required a much greater precision than that for other sciences. In zoology and botany, an individual specimen can have great importance, but a rock specimen on its own has no value if you do not know the precise point from where it has been collected, the rocks on which it rests, the layer it has been taken from, and those which overlay it. The making of geological observations must always proceed by the exact and precise knowledge of the places and the descriptive anatomy of formations. It is only after this study that general considerations of the origin and the age of regions can be raised. With this statement, I'd like to conclude by acknowledging and paying tribute to the scientists, non-naturalists, the officers, and the commanders of these expeditions who often knew as much about natural history than the naturalists themselves. And that included Dumont. So thank you very much for that.